Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net.
Programming Throwdown, episode 36, Swift. Take it away, Jason.
Hey everybody. So last week I was involved in this hackathon, which is, for people who don't know, it's basically, you have some kind of a theme, and your goal is to rather quickly come up with some prototype which which demonstrates some cool some project that you've been working on. So for example, there might be a hackathon on, say, HTML5, and you make some cool way to show videos in your website that's never been done before, or something like that. It's pretty cool. It's a lot of fun. I've done a lot of these different hackathons and these 24-hour code challenges and design challenges and things like that. And Patrick, you've done a lot of rapid prototyping with Arduino and along those lines. And it's a lot of fun. Everyone who's if you're from a hobbyist to a professional, you should definitely give it a shot. There's a ton of them on the internet. If you're into games, there's the Ludum Dare challenge. There's a ton. I'm sure whatever topic you're interested in has some kind of hacking contest, and it's cool. It's a chance for you to sort of showcase something to the rest of the world, or at least to a community of like-minded people, and get feedback and things like that.
So you would recommend hacking at hackathons?
Definitely hack at hackathons. Yeah, definitely. I think sleeping at hackathons, I wouldn't recommend that. That typically doesn't happen.
That was what I would do.
Yeah, that's what you do. For people who don't know, Patrick has to get his 8 hours. Otherwise, he turns into Angry Patrick.
I don't know what you're talking about. 8.
You get 9 hours of sleep?
Most nights. Oh, man. I'm totally a terrible person, dude.
Terrible person.
I need my beauty rest.
Oh, man.
So we gotta...
Go ahead. But yeah, in general, a couple of tips for these hackathons. Number one, go with a plan and focus on the plan. Start with the UI. It's a complete opposite of an actual project. You want to think about it this way. Think about, at any moment the hackathon could be over. Even though that's not true, there's usually 24 hours or something, but just treat every hour like it's your last hour. And in the sense that don't spend every hour killing yourself as if it's a deadline or anything, but after 1 hour you should have something that you can at least look at, even if it's just an empty screen. After 2 hours you should have something, and kind of work backwards, and you'll find that a lot of your ideas that get thrown out are really ones that didn't matter. For example, in this hackathon, I wanted a settings page where people could sort of customize their experience, but I started backwards from the experience and I never got to the settings page. And if I had done that in the opposite order, I'd have nothing to demonstrate. I'd be like, hey guys, here's my project. It's a settings page. And I would have totally bombed. So, it's really good. Rapid prototyping in general is a really good skill. And I say skill because it's not something you can learn. You have to just cultivate it. And I highly recommend it. So.
Yeah, I think that's good advice, to do it the opposite way you would normally do it. But I know a lot of people, I guess you should somewhat, that mindset is applicable to everyday life or everyday work. But I agree. I saw a lot of people, whenever you do these kinds of things, or even in school when people work on projects, they would end up with some sort of what they would call tech demo at the end. They would worked a lot on some piece of infrastructure, and then in the end they ended up with kind of nothing, because they didn't, it was just some sort of processing in the background and no kind of good visualization way. If you start kind of faking the data and make it look nice, and then kind of work back to actually make the processing, it's easier for people to imagine or believe that you can do the hard part in this scenario. So for prototyping, exactly. That's really useful. Is it worth investing in actually getting the algorithm to work right? Now, in real life, you may actually, that is the key point, right? And so you don't care about the other stuff. But for demos, it's much easier if you can say, here's what it will look like when the algorithm works.
Exactly. That's exactly right.
Yep.
You have to sort of like, as I said before, you have to like plan beforehand. And that part you can do like kind of bottom up. Like when I had planned it before the hackathon started, I'd kind of started with the settings page and kind of drew little diagrams of sort of how I wanted it to look. But then when I actually got to coding, when they started the clock or whatever, then it was all about the UI. So yeah, it's a lot of fun. You guys should definitely try it.
So this week we have a question from Mike, and I'll summarize. He wrote a little bit more, but that basically he's still in school, and that he gets, every time he asks for career advice, people say to get involved in open source projects or communities, and he was asking if we had any recommendations for that. Specifically, I actually don't have a great recommendation for an open source project to join. I too also got this advice when I was in school, and had the same thing. If you ask people, well, what open source project is good to join or is open for contribution, you always get this like, we'll first start by helping to document the project or looking at the bugs and trying to fix bugs. But there's a lot of work you have to do to get it to that point on any kind of mainstream open source project that you would know. I'm not saying you can't do it, and I know people vaguely who have done it before. But I think a lot of the open source project opportunities that you should be most interested in first are the smaller projects. Like maybe it's just one guy who has some interesting tool, and you think of a new way that the tool could work. Because if it's just one guy, it's much more likely that you're able to kind of understand the code base and make contributions more quickly, which in my opinion, when you're first starting out, is a better feedback mechanism, because you see your work actually leading to something versus just spending like 6 months trying to figure out where to put your code. You can actually make a contribution, or even creating your own open source project for something that you've been using, and you think, hey, this might be helpful to someone, and posting it up and see what other people. Now you may get harsh criticisms, or shocker, the internet has some people who are jerks, and they may say mean things about it. But some people will have legitimate, like, hey, you may want to consider this, or you have a security problem here, or whatever. And then that feedback can be really helpful. And I think as far as like when it comes time for a job, you'll have learned some stuff there, and you'll have something to point people to and say, here's work I did. But don't feel like you have to join like OpenSSL and make contributions, or the Linux kernel, or one of these really big open source projects. Don't feel like when people say that that's good, like those are what they mean. There's a whole range of things that you can do.
Yeah, definitely. I mean, I feel like unless you're actually contributing to the Linux kernel because it's your job or something like that, like a lot of those huge code bases are actually a nightmare. And it's nothing against them. It's just that's just a lot of these things grow organically, and they don't grow in the most pristine way, right? And so yeah, as Patrick said, your best bet is choosing something small and starting from there.
Yeah, and there may be exceptions to the rule, but it's the same thing like whenever you start a new job or join a team. It's kind of weird because they went through a lot of effort to get you or hire you or bring you on. But then it's always like, it's been my experience that many times when you first join a team, nobody kind of has the time to help you. Everybody's too busy to help you, right? They need your help, but not right now, because they don't have time to kind of help you get started. And so,
right.
Nice people will point you in general direction, but you spend your first few weeks kind of twiddling your thumbs a lot because no one has the time right now to help you with something. And I think that's just kind of one of those facts of life, of way things work out, that open source projects are probably similar. The guys or girls contributing are spending their time doing their contributions, and then bringing on new people is probably like a second priority to them. And so it's, like again, except maybe in some exceptions, they're probably more interested in spending their time actually doing the work.
Right.
And so that's what makes it difficult to join if you're not just super, super self-motivated, which some people are. And, I'm glad there are people like that in the world.
Yeah, definitely. Yeah, that's really good advice. Start something small, preferably something you work on yourself. And, GitHub has kind of reached this critical mass now where, I don't know about you, but I tend to like search specifically in GitHub for projects. Like the other day I needed a Node.js LDAP library, and I just went straight to GitHub, and I found some guy's library that he wrote in his spare time. It's just a one-man operation, and grabbed it, and I found there were some bugs in it. I filed bugs, I made some changes, and so if you put your project on GitHub, write some decent documentation, and if it's something pretty niche, or you're doing it better than everyone else, you'll generate interest.
Definitely. All right,
Cool.
Time for news.
So yeah, I think this might be the first time on the show we've ever made a mistake.
No,
I'm pretty sure.
it may be our first legitimate official retraction, but
I went and I listened to all the old episodes, and it turns out we never made any mistakes until now. It's shocking. But so we announced last episode that Twitch was going to be bought by Google. We showed what Luddites we are when Twitch got bought by Amazon a few days ago.
it turns out people were overstating their belief in the rumor that Twitch would be bought by Google, and we, like the terrible people we are. Man, I'm saying that too much tonight. The people we are, the innocent, not believing that the internet could ever have a lie on it. We just took it and said, "Oh, that must be true." And it was not.
According to this Forbes article, they were about to be bought by Google, but there were some issues related to antitrust and things like that. Actually, let me be more clear. There were issues about the potential of antitrust litigation that could happen, but didn't actually happen.
So JC has no idea, and he's not a lawyer.
And
it's all this part is all still rumor.
That's right. That's right. Well, it's on this Forbes article. But yeah, you're right. It's not validated in any way. But yeah, so Amazon bought them, which I think is pretty cool. I personally have never liked the YouTube kind of user experience. In fact, if you want to see the current live streams on YouTube, you actually have to go to this crazy YouTube / and then this hexadecimal string. And that's the only way to get a list of the live streams. And so, I know that YouTube's live streams aren't really their thing, but still, I feel like the UI, I just never really been happy with YouTube from an experience standpoint. And so, it's kind of
specifically for live streaming. That's what you're talking about, though, right? Or in general, you just don't like YouTube.
I like the service. I don't feel like the UI, the user experience is there.
Right.
That's my opinion.
Okay.
Anyway, I can go on a soapbox about that, but I'll spare everyone. But and actually, a lot of the internet, a lot of Reddit and things like that have echoed similar statements.
So you read something on Reddit. I see now. I see where this is going.
Yeah, I've been blinded by Reddit. No, but actually, it was kind of, for me, it was a little bit of it was kind of a relief to see other people thought the way I did, because sometimes I think I'm just crazy.
No, that's true.
Well, yeah, that's also true. Anyway, so they got bought by Amazon, which is pretty cool. My guess is that Amazon will leave them, as is. Amazon tends to do that with a lot of their acquisitions. They don't really, try to run their life or anything, which is pretty cool. I think Twitch is pretty great. I've actually been listening to a lot of streams while I've been working.
So last time we talked about the Dota 2, the international.
Mm-hmm.
What have you been watching on Twitch since that's over now? So you obviously weren't watching
there's
that.
A guy who, you're not going to believe this. There's a guy who...
Is this Fish play Pokemon?
I've seen that, which is pretty awesome. I've also seen Goldfish play Street Fighter.
Oh, maybe that's what I'm thinking of. I don't know.
There's both. Both. But the one I saw is this guy, he's a chef, and he just kind of talks about food and stuff. And he also does these speed eating challenges.
So this has nothing to do with video games. So you watch live streams of non-video games.
Not really, yeah.
So I thought Twitch was solely about video games.
Well, it could be whatever you want, right?
I don't know.
They can't really...
I don't know. I've only ever watched video games on it.
It is video game centric. There's no doubt. But there's nothing to stop you from doing whatever you want, right?
Okay.
So this guy actually, the last time I heard him, he ate a pizza, a medium-sized Domino's pizza in 1:16 seconds.
That's just gross.
I know, it's unbelievable, and you just gotta see it. If you go on YouTube, you can watch a replay.
Wait. So
go on Twitch.
I can go on. Oh, this is confusing. I have to go on YouTube to watch a replay of a Twitch TV live stream.
Yeah, or maybe you can watch it on Twitch.
Okay.
Does Twitch have replay?
Okay.
Anyways, this is a digression, but you should watch it. It's pretty cool. Just put guy eats Domino's pizza in 2 minutes or something like that.
Okay, guy eats Domino's.
His name is Caleb Hart. So Here, I'll put it in parentheses in the show notes.
Okay.
But yeah, it's pretty epic. It's a very large man, and he eats a pizza very quickly.
Okay. Interesting. All right, I'll have to check that out later because I'm going to get distracted if I read that right now. So my next news story is not a news story at all. Well, it's not really news, but it's a blog post that I read, and we were discussing this at work and sharing our anecdotal stories about it. And the guy, the blog, well, you'll have the link in the show notes. But basically, it's called Norris Numbers. That's the title of the blog post. Makes it always sound awesome. I wish I thought of cool names to title stuff like this, like the Norris number. So this guy is writing about a friend who has a quote about a friend or something who's called Norris, Cliff Norris. And he says that the Norris number is the amount of code an untrained programmer can write before they hit a wall. And so they were talking about like the estimates of it or whatever, like 1,500 lines of code, 2,000 lines of code. Now there's a whole thing you can get on about if a line of code is a good measure or bad measure or what it measures. But leaving all that aside, I feel like this is a good point that when you talk to people who are just fresh out of university or while you're in university or school, that you write code that's very certain manner and very like architecture seems to be really lacking in most of those projects because it's not what it's about. And you'll never write enough code that architecture will kind of really matter because you're not going to maintain it. You only are going to work on it for a few weeks. So you can just kind of spit out code and you in some ways are very efficient because you know you're going to stop. But that kind of doesn't work in the workplace. But yet in the workplace, the coding initially kind of comes out the same way. And it takes kind of training and thinking and experience to be able to kind of write something more than these people are claiming about 2,000 lines of code. We'll go with that for now. So once you get above 2,000 lines of code, for instance, you start having problems like if your organization of what code is in what files or what classes and how the data flows, not a performance problem, but a like how do I move around the code? And if someone else might be working on it, right? Like how do we work on two things at the same time? So you have to kind of learn those things before you can get to, they're saying the next wall, which this guy's saying is like 20,000 lines of code. And when you get to 20,000 lines of code, that you can still kind of have like a, loosey-goosey approach if there's multiple people, for instance. But then if you want to make it to like 200,000 lines of code, you need even more very strict organization. You need like someone really writing for instance, like style guides because you need the code to be consistent, deciding what goes in and out of the project. So like not adding features just because they might be nice to have, but actually only writing the features you need. And so he's just kind of talking about these like leveling up as a programmer. And I thought it was an interesting read because I personally, I don't read a lot of articles that talk about the craft of programming like that. And so it was kind of interesting to read. And then thinking in my own kind of growth, how that like, oh yeah, initially you write spaghetti code and then you realize like that doesn't work. And then you do other stuff and how that like as you're leveling up the complexity and size of the project, how you have to bring new techniques to bear. And a lot of times you don't know them initially, like you don't know how to write a 200,000 line of code project. And then you kind of learn it over time and figure out what works and doesn't work. But then you keep hitting these things that prevent you from growing even bigger.
Yeah, this is really interesting. Yeah, I think it's really interesting because you can kind of see the wall coming. Like, for example, there was one project I worked on where there was effectively like a main control loop file that was, like 20,000 lines of code in one file. And you just know that the wall is like imminent, like you just know that like what they're doing isn't scalable. I'm sure, even if you look at smaller projects, you could start to see something where it's like, okay, this is going to end badly.
Yeah. And in one measure is kind of velocity, right? Like, and even this is a little off topic from what this is talking about, but I've noticed in my own projects that when I work on them at work, that you go through these cycles, and some people call it like technical debt. But like if you can keep throwing more people and work harder and trying to like add more features, but at some point, if you're not kind of thinking through like re-architecting the system, you eventually get this organic growth problem where you start to lose a lot of velocity and trying to just keep things working. Right. And then you have to kind of do a re-architecting, and then you can go really fast again.
Yeah, like a very common problem you see is like, for example, there's some class and the class's variable called, latitude. And then you end up with like another variable called previous latitude. And then somebody realizes, oh no, I need 3 levels deep, so I need like previous latitude. And then you find out, oh, I need an array of latitudes, like a history. So you create like a array called like latitude history, but then you're in a hurry, so you don't delete the previous latitude. You keep it around. And then like you can just see like this, and you just know that this is going to end badly, or like you're going to need some kind of major refactoring at some point.
Yeah, the current problem I try to work through is whether or not, like, when you first start a project, how much time do you spend architecting? Because you could spend kind of an infinite amount of time stuck trying to figure out what to do without ever doing anything. And so you've got to get started at some point. So you kind of have to pick the lines, even if you know the requirements may change. So you kind of have to do your best and trade off like getting going versus flexibility. Because you could write the most flexible system in the world, but it doesn't do anything. It's just really flexible. It
That's
can
right.
do
Yeah,
anything, but it does nothing.
Yeah, you have to make the trade-off between being data-driven and building a Turing machine, right?
Yeah.
I mean, like on one end, you want, for example, like CSS, right? If you're building a website, you don't want to have all of your style in the HTML, and then every time you want to change, or in the JavaScript, and every time you want to, make a font bigger, you have to go and hack code. But on the flip side, you don't want to create some like wild, thing that compiles to something which compiles to CSS so that you can just like write everything. Then you've basically just like kind of created your own language that you're going to have to code in, and you haven't really gotten anywhere. And so somewhere in between there is kind of the sweet spot.
Yep. All right.
Cool. So yeah, my next news is also not really a news, but it's a really, really good read for people who are interested in this kind of sampling methods. It's called Gibbs Sampling for the Uninitiated. And as the name suggests, or as the name actually just outright says, you don't have to be initiated on Bayesian methods or sampling methods to understand what's going on in this paper. But just to give you kind of a little preamble, so this, have you seen this where if you have, say, like a circle inscribed in a square and you randomly throw darts at the square, you can estimate. One thing is, let's say you have some circle inscribed in a square, and you want to know the area of that circle, or you want to know a random point on that circle. Let's start there. So one way to do it is to just throw darts at the circle randomly, or throw darts at the square, because you can easily do that. You just pick a random X within the range of the square and pick a random Y, and you throw a dart there. If the dart hits the circle, then you use that point. You say, here's my random point on the circle. If the dart misses and hits like the little corners around the circle on the outside of the circle, then you throw another dart, and you don't count that dart. And so it turns out, this is called like rejection sampling. And so it turns out like this is fine. Like doing these darts and throwing some of the darts away is the same as like from a math standpoint as like picking a random spot from the circle. But it's a lot easier to do because it's easier to pick a random spot in a square and then throw some of them out than it is to like figure out the equation for all the random spots that could be in a circle, right?
Okay.
So this is sort of like an easy way to do a hard thing, right? And so you can actually
But you still have to know what's in the circle versus not.
That's right, because it's easier to know whether you're in the circle or not than it is to like know the distribution of points in a circle. Like that second one is hard,
okay,
right? So and you can do this to approximate pi, right? You can that if you throw like 100 darts, that all 100 of them will end up in the square, but some fraction of those darts will end up in the circle. And then based on that, you know the area of the circle, right, as like a fraction of the area of the square. And then you can actually approximate pi, like if you throw enough of these darts. So this is an idea where like you use a bunch of random numbers and you figure out, like in this case pi, you figure out the value of pi by like what's called Monte Carlo sampling. You just try a bunch of random numbers, and slowly the number you're looking for gets closer and closer to pi, right? But you can also use it for distributions. Like as I was saying, if you want to pick a random spot on the circle, you can use this rejection technique, and you can effectively like sample from the circle. And so like if you're doing like computer vision kind of stuff, this is pretty useful. So this is cool for say like circles, but if it gets really complex, and like in some high dimensional space, you're doing some machine learning and you need to sample from some really complex shape in a really high dimension, then like these rejection sampling techniques break down because you end up just rejecting everything, or rejecting like 99.9999% and just nothing gets done. So this is one way to deal with that. It's called Gibbs sampling. Hopefully they do a much better job than I just did talking about this whole thing. It's pretty complicated to cover, but it starts you from the ground up, and it starts by talking about just like basic statistics, like counting and things like that, and they work you through going from there to this Gibbs sampling, which is kind of like the de facto way to solve this problem. So I thought it was a really great read, and I thought for people who aren't familiar with this and are interested, they should definitely give it a shot.
I'll have to try. I skimmed it, but uninitiated doesn't mean ignorant. So I need Gibbs sampling for the ignorant.
Need the dummies for dummies.
Yeah. So I guess this could have been the tool of the show, but I didn't have time to try it out. So just making it a news item. Hyperlapse is a new app released from Instagram, and I saw something similar from Microsoft, and I don't understand the connection. I feel like it was also called Hyperlapse. But this Hyperlapse from Instagram allows you to record a video on your iPhone. I don't think it has Android yet, but iPhone, and like you walking down the street in New York City. And of course, like as you walk, the camera moves up and down. It's not stabilized, right? And so then what they do is make a kind of a time lapse where they fast forward you through the video, but also kind of stabilize as you go. So you've probably seen these effects in various movies or commercials or whatever. Or the other classic one is like you point at the clock in the center of Grand Central Station. There's some fancy clock, and you point at that, and you have all the people like whisking around you, right? And so you could set up a tripod and do this, or if you could stabilize a video, you can just kind of hand hold it for a while, and you get these really interesting effects. Instagram's all about filters, I guess. Well, it's all about a lot of things, but people on Instagram like filters. So this is using time as a filter, and it seems pretty interesting. So I'm definitely going to be checking it out. But I think it just was announced or released like today, 13 hours ago. It says so. This is like fresh off the presses.
Is this the same as the like in Google Plus? They have the Auto Awesome, where if you take a bunch of pictures that look like they're a sequence, it'll build a movie out of it. Is this the same thing, or is this different?
So, but that doesn't try to like give a coherent viewpoint, for instance, right? Like it'll just stitch them together.
Right.
This one actually takes video and essentially tries to make a cool looking fast forward of the video that's stabilized. So if you just fast forward normal video, it's kind of like blurry, but this stabilizes it so it actually like.
Oh, now I see what you're saying.
All right, yeah,
so
you just watch the video.
Yeah, okay. Yeah, I'll check it out. It sounds cool.
So it definitely is. It's cool. It's just like a better fast forward, basically.
Okay.
So, because you have certain videos that are cool, like you're, on some beautiful drive through a cool town, or on like a train or an airplane or something, and you're flying over stuff, and it's cool. But if you have to watch it at real time, it's like very boring. No one wants to watch it.
So wait, what's wrong with watching it in fast forward? It's blurry?
Well, it's not that it's kind of blurry because you're bouncing around, right? Like the train is vibrating a little.
I see.
And
so
you're kind of like moving left and
it.
right. So they're trying to pick a point and kind of keep the perceived viewpoint as if you were stabilizing the camera, as if the camera is being held very stable at a certain point.
I see. So they're like basically registering the frames
Yeah.
together,
Yeah,
and
yeah,
then
yeah.
like, okay, got it.
And there's some
Cool,
stuff about
cool.
how they did it we can read about. Anyways,
Yeah,
should
I
check
need
it
to
out.
jump on the Instagram thing. I totally missed that boat.
I missed every vote.
Yeah, we were just talking about this before the show. We are not socialites. We're the anti-socialites when it comes to social networks.
Okay. Book of
At
the
any rate.
show.
My book of the show is Denial: Why Business Leaders Fail to Look Facts in the Face and What to Do About It. So this is pretty interesting. It covers several different companies that have either completely failed or had to reinvent themselves. And it goes way back in time. It actually covers Henry Ford and the Model T. So for people who don't know, someone told Henry Ford, "Hey, we should do the Model T in different colors because there are people who like the aesthetics, changing the aesthetics." And he said no. And then other car companies started making cars that were red or yellow or painted however you want, and people loved it. And he still said no. And then people stopped buying his cars. And that's how that sad story ended.
That was a really sad story, actually.
Yeah, and a lot of these are actually quite sad, but there's a lot to take away from them. I haven't read the book yet, but it is recommended to me by a friend, and I'm definitely going to give it a read. But it covers tech industry. It covers various ones. There's actually how they have the tamper-proof seals on like pretty much everything. Like water has a tamper-proof seal now. But that all started because someone who is just a sociopath was poisoning bottles of Tylenol. They're actually taking capsules of, I think it was like cyanide, and that were white to look like Tylenol capsules, and putting them in Tylenol bottles and killing people. And of course, people's natural reaction is to blame Tylenol and sue the Tylenol company. And after many months, they found out that it was this sociopath, and they caught him and everything. But this is all about sort of how they dealt with that, because from their perspective, they just saw people using Tylenol and dying, right? And anyways, all of these, each chapter is a different company with a company breaking pandemic, and how they dealt with that or didn't. And so I just thought it was just a phenomenally interesting idea, and I'll definitely be reading it this week.
Mine is not nearly, well, maybe it's more interesting, less interesting. It doesn't seem as applicable, as useful to your life as Jason's nonfiction book. So previously I had recommended a book by Scott Lynch called The Lies of Locke Lamora. And this is actually a series. And so the next two books, Red Seas Under Red Skies and The Republic of Thieves, I've read both of them now. And so I will recommend them as well. Basically recommending now at least the first three books. I really liked the first book a lot, and the second and third book didn't disappoint, I guess. They, when you read a first book, sometimes like a whole new universe, right? So it's kind of hard to keep it up through many books.
Right, especially if they didn't think they would be writing a second book.
So I think this person did, Scott did, and they did a good job. So it's not like world building as much. Like there's a lot of weird things in the world, and they've not really revealed much more, I guess. But, the story advances, the characters advance, and I kind of like the second book. I like the first book a lot, and I think I like the second book a lot too. The third book I'm kind of wishy-washy on. I'm glad I read it because I wanted to find out what was happening to the people. But I didn't care for the style is different, actually, in each of the three books. Like, instead of the same thing, like, you read some books, like, I'm trying to think of a good example. Some books, and like the same things happen to the characters every time. Like the characters don't seem to be learning. And it's just a good story, right? Because like, it's like, like James Bond, like a James Bond book, right? Like James Bond doesn't carry over. He doesn't really get better or smarter through each book. And sometimes the books are about like the characters getting smarter and more powerful as the books go on. And then in this one, it seems almost as if they're just putting them in very different scenarios and almost a different style of writing for each of the books, and I kind of enjoyed that.
Oh, cool. Yeah, I'll
So.
check that out.
Time for tool of the show.
All right, I'll try not to go into hyperbole here, and I'll save a little bit of time. My tool is actually rather simple. It's Nextdoor.
Wait, you left it next door?
It's yeah. So it's pretty cool. Basically, you validate your address with them, and there's just a variety of different ways you can do that. And then it's effectively yet another social network that I probably won't participate in. But this one's kind of cool. You know, if you're having like a garage sale and you want to know if like your neighbors want to have a garage sale with you at the same time or something like that, you can basically, it's like you can think of it as like a forum or a message board, but it's private to your neighborhood. And there's a separate message board that's private to like all the neighborhoods within 5 miles. But because you've validated your address, you typically don't have to worry about spam and things like that. At least I haven't
heard
yet.
about this.
Yeah, it seems pretty cool.
And they were
You know,
saying actually like a ton of people, like a lot of neighborhoods have been registered already on this. Like it was kind of crazy like how much it's catching on, but no one seems to really be talking about it yet.
Yeah, I mean, you know, I signed up. My neighborhood was definitely already on. There's a number of people from my neighborhood who are already on. You know, what I've found is I was just browsing some of the content, and I just didn't see a lot of content. I mean, there's maybe one message every 3 months, and most of the time it's just complaining. It's not really useful. So that was kind of sad, actually. But, you know, we'll have to see what develops. I mean, you know, this could, I see great potential. Yeah, it's just a matter of, you know, whether people will realize that potential or not.
Interesting. All right.
Yeah.
My tool of the show is Waze, GPS navigation app, and as if we needed another. But this one is, I has some features I like. So it also has some sort of social networking points earning thing that I don't use. But the idea is that some people do, and it makes the network better because what it tries to do is use, I feel like we had to have talked about this before, but I looked it up and I haven't seen it. It didn't come up that we had talked about this before. So if I did, I apologize. But if not, this is awesome. Ways people enter like there's a policeman ahead, or you know there's a traffic camera here, or you know there's a traffic accident, you know, on the right side of the road up ahead, and people enter these things. And so if you keep the app up while you're driving, you'll get alerts coming through, and it'll ask you to even like validate, like, do you see an accident up ahead, right? So they know when it clears and stuff. And gives warnings. But the thing for me, it seems more like every GPS app now says that they do kind of real-time traffic, but this one seems to do a better job of it because they seem to be more quick about feeding back in like actual user reports and stuff. And it'll even show you on the map like all the people driving around who have the app open. So living in the San Francisco Bay Area, there's like, I forget, like each morning it tells me there's like 2,000 people using it.
Wow.
Which is not a ton, but like in a commute, there's already like 2,000 people on the road. And if you kind of spread them out, this is not that big of an area. So that's a lot of data points that they get in real time.
Yeah, it's great.
And they're feeding it back in, and it works really well. They're now actually owned by Google, so I guess they'll be integrating something with the Google stuff soon.
Cool.
But I like this app, and I use it every morning to check which. I have several potential ways I can go to work, and I always look on this and see which way I should go. But yeah, like all GPS apps, there's slight problems where like if I leave now and my commute's a little longer, so by the time I'm halfway through, right, it's like 20-30 minutes later, so traffic has changed a lot.
Oh yeah. All of a sudden there's an accident in front of you and you can't really do anything about
but they
that.
know like every day there's at least one accident, so I feel like they should know. Anyways.
Yeah, that's right. They should just predict like Patrick, what are you thinking? Come on. You know that I'm going to give you an accident.
So yeah. Anyways, all right.
Time
for discussion of Swift.
So Swift is a new language that was introduced by Apple, I guess a month or two ago, but has been in development for a few years now. And basically, the point about Swift is to replace Objective-C. So, Objective-C was popularized, as being the only language which you could use to make iPhone apps. Um, and it's also used to make OS X apps and things like that. And Objective C is a open source, has an open source compiler, so you could really use it to make anything in theory. And so Swift is meant to sort of come in and replace Objective C, and just kind of make developing for any of those devices a little bit easier. So it has a variety of features, many of which we've talked about on other episodes, but we'll cover them briefly. So it has static typing with type inference. So if you listen to our Haskell episode, you know all about that. But basically, it has the static typing, so you can't try to set a int equal to a string or anything like that. But most of the time, you don't have to put the type either, which is what makes the dynamic type languages popular, right? You can just say I equals 3, and it knows that I should be an integer.
But it has to be an integer from then on. Well,
that's
from
right.
Then on. It has to. Right. Every reference of I needs to be an integer.
That's right. But I feel like that's true. I feel like with dynamic languages, you should be doing that anyways. I mean, that's like a personal, that's a pet peeve.
There should be some reason. There's probably some clever thing you can do where I can be equal to literally anything, kind of the null pointer hack. But also null pointers are dangerous, or void pointers. Sorry, not null pointers, but void pointers.
Right.
It's kind of the same thing. A void pointer can be literally anything you want.
But yeah, it just leads to just drama. Yeah. So it also has generics, which is huge. I mean, Objective-C still had like just array, and then if you wanted like an object out of the array, you had to say like, get me the item at index 1 and then cast it to whatever. And theoretically you could have an array where the first thing's a string, the second thing's a number, a third thing is something else. And that's a terrible idea. Don't ever write code like that. I mean, if you really need, like, for example, think about like say JSON. In JSON, an array could hold, numbers and other arrays and maps in it, right? So like create a class that has those three things and make one of them non-null, right? Like don't try and rely on the compiler and the runtime, casting to solve that problem for you, So
generic is like pair. So you say like, I want a pair, but I want both things in the pair to be of the same type, but I don't know which type they will be.
Yeah, exactly. So with generics, that's when you're writing the pair class. But as someone who's using the pair class, you could say like, this is a pair of an int and a double, or this is an array of strings. Versus Objective-C, where everything was just a pair and array, and you used casting to talk about what you meant. It has string templating, which is pretty awesome. It's something that not a lot of people take advantage of.
So you mean built-in support for this, or is this a library that they have?
A built-in support, yeah. So for Java, for example, you have to use the string template third-party library to get this. But in general, this is pretty awesome. I mean, basically, you could imagine like having a string and then saying like embedded in the string could be say like %name%, and then wherever you see %name%, it changes it to some variable. So that's basically what templating is, and it's a way to sort of write code that's very data driven.
So the way this works is like if I have a string that says hello %name, I don't know, is that the syntax? Hello.
Yeah, the syntax, it's like slash open parentheses and slash close parentheses. But yeah.
So if you have hello and then the special thing indicating name, and name is currently set to JSON, and then I say print that string, it'll say print hello JSON. And then if I say the string is now equal to Patrick, and I print the string again, the name is now equal to Patrick, and I print the string again and say hello Patrick.
Exactly.
Okay.
Exactly.
All right.
Yeah, so string templating is very useful. It has closures and it has functions as first-class citizens. So I think we talked about these in the Haskell episode. So one thing you'll notice already is that Swift borrows a lot from functional programming. And so it's actually very similar to Java 8 when that comes out. So you'll notice a lot of similarities there. It also has operator overloading. which is pretty cool, especially if you're doing math stuff. Like I don't know if you've had to deal with this, Patrick, but like in these like, have you ever used like the Java matrix libraries or vector
I have
libraries?
mixed minds about operator overloading. Sometimes it's convenient, but sometimes it's not, because if, like I'm not a high level algebra person, but like, I kind of have like a feeling for how a plus should work. And so if you have something and define the operator as plus and the plus doesn't work kind of how I've conceptualized it to work, it's kind of bad, because I tend to just use the plus without going and looking up the comments you wrote about how plus works. Versus if you wrote a function that I had to call and I needed to go look up the name, I'm probably also likely to read the comments about like any sort of warnings or, the exact usage of it. So for me, operator overloading is kind of scary, because I've had instances where I used an operator that I thought should work in a certain way and it just doesn't.
Yeah, that makes sense.
I'm trying to think of a good example off the top of my head, but I'm not. It's escaping me right now.
Yeah, I mean, well, one of them, the one I've seen is, when you have two vectors and you do multiply.
Yeah, that's a good example.
Sometimes you get the dot product, or sometimes you get a vector where it's like component-wise multiplication.
Yeah.
And it's like you kind of really know what you're going to get. I do see that as a problem. I think, I've been like, not burned, but I've been frustrated with doing like matrix operations in Java. You end up with this mess where it's like a dot add parentheses b like dot multiply. You know what I mean? It just it looks so hideous.
Yeah, and I think Haskell had a good way of dealing with that, where like you can write any function as infix. So like you're saying, like a dot add open paren b, right? You can just write A add B.
Oh yeah, that's right.
So you can do or you can say add A B. Yeah.
Yeah. Right.
So you can do them. Yeah. So you can get what you're talking about. Like I think that's kind of like, well, I mean maybe it's not as easy to do in something like Swift or whatever, but I think that's actually a really nice feature of Haskell, that you can do it that way, so that you can actually write out the thing, but use it in the middle if you want.
Yeah, that makes sense. Yeah, I think that. Like, I think both of these are good. I think the Haskell idea is probably, I agree, it's probably better, because you could have a name that's pretty descriptive, like a mult piecewise or something, instead of using a multiplication sign. But yeah, either way, it's I think it's both of them are better than the Java 7 way. I think Java 8 has operator overloading, but at any rate. So those are basically the big features. You'll notice like Swift, by itself, it doesn't really do anything brand new, but it takes a lot of ideas from different languages and kind of brings them together, which is pretty cool. It's using LLVM. So I think we've talked about LLVM in the past.
I'm sure we have. But go ahead and do it
LLVM
again.
stands for low-level virtual machine. For example, like say Java, you write Java code, and then the Java code gets compiled to what's called Java bytecode, and then there's a JVM which executes that bytecode, right? So LLVM, and also another one called CLI, which is Microsoft's kind of version of LLVM, and it's for C# and VB.NET and those things. So both of these guys kind of take it to the next level. So they have an LLVM interpreter, just like Java has the JVM. They have the LLVM, and you can compile your code to bytecode and run it just like you can in Java. But you can also go from LLVM bytecode to machine code. So that's the thing that Java does not have. Now, if you go to machine code, there's no going back, right? I mean, like now you've built something that only works on, an iPhone or something like that. But that extra step allows you to do sort of a lot of cool optimizations, while at the same time having the advantage of the VM when you need it.
It also has the advantage that,
that
for optimization, you can do work on, if you're a person interested in taking something from the LLVM bytecode to the machine code, and coming up with clever ways of recognizing patterns of operations in the LLVM bytecode, then and producing machine code that's optimal for whatever, like Pentium 3s. I don't know. Nobody uses those anymore. But Pentium 3s, like that just for some reason has this one instruction that you love, and you figure out a way to generate bytecode to that. Then anyone who has any language and the front end compiles into LLVM bytecode can take advantage of that optimization for Pentium 3s. So whether it's coming from Swift or Objective-C or regular C, if it's in that intermediate format of LLVM bytecode, you kind of don't care where it came from because you can recognize patterns there and produce the optimal machine code.
That's right. So both Objective-C and and Swift go to this LLVM bytecode, and then from there they're both treated the same way. So all the work that's gone into, going from LLVM to machine code for Objective-C doesn't have to be duplicated for Swift.
Yay for standards.
Yeah, that's right. Well, isn't that weird? It's kind of like a standard by example. It's not really a standard, but it's like it's a reference.
Well, so I mean, the alternative, and this starts to get a little outside of where I have a lot of knowledge about, but the alternative, if you take kind of the GCC project, they also use they don't call it bytecode, but they have an intermediate language. So their front end's compiled to this intermediate language, but they kind of only ever meant for it to be used by their project. And so it has all sorts of nuances and complexities, and it's very difficult to work with. But it's very, very optimized. Like you get really good code out of GCC a lot of times. But this LLVM was kind of from the ground up always intended to be used in this way by many, many different front ends and for producing optimal against different back ends. So they kind of designed it that way. So they made certain choices that kept it easy to use.
Yeah, exactly.
So yeah, it's not really a standards. Like I don't think there's a standards body that does it, but like they made it and said, hey, this would probably, other people might want to use this as well.
Yeah, definitely. Yeah, I think it's interesting. Like, it's sort of like a standard just by being a reference.
Yeah, I guess like you said, you had a good way of saying it. Standards by example. It's not really a standards. They just made it open source, and because they did a good job, it's become a de facto standard. There we go.
Yeah, that makes sense. So yeah, it's optimized for mobile, clearly. It has very good integration with Objective-C, as you might expect, because they're both, compiled down to the same thing. So basically, have you ever used Swig, Patrick?
No. I'm going to go with no. Okay. I think I have, but just go with no.
Okay, just go with no. So yeah, Swig is this thing that kind of it inspects your code and it generates stubs in another language. So in other words, let's say you have a bunch of C++ code, you use Swig, and you can create like Java files, like Java source code, where when you call one of the Java functions, it knows to go and call the C++ function. This works kind of similar. So there's an idea called a bridging header, and you just tell Xcode in the project what Objective-C files you need to access from Swift and vice versa. And then it, for each of those files, generates a bunch of wrapper code under the hood. It's pretty cool. It just it's one of these things that just works. So the functions in Objective-C, you can just call them from Swift and vice versa.
I hope it works better than
extra step.
swigging C++ code into Java or calling into C++ from Java, which I have done before, but yeah, it was always kind of messy and it never works quite like you want it to.
I think the issue with the C++ to Java is they have different VMs.
Right. Well, that was always a problem. Like, kind of different binaries, right? Is one way of kind of saying it, to hand wave a little. So you have like the C++ needs to be compiled in one way, the Java in another, but then the Java needs to know how to call into the compiled C++, and then how to interpret kind of the results that come back. Because like they use a different standard for it.
C++ is not a VM, and Java is the JVM, And so there's not really like a meeting point there. I would imagine that if you built C++ code with Clang, and if Clang had a Java compiler, I don't know if that's true or not, or rather if LLVM had a Java compiler, then maybe you could do something more sophisticated, because then like those two languages are meeting at the LLVM level.
So like I know there's Python can call into C++ code. It's much cleaner.
Yeah, like there's the Boost Python. I've seen that.
Yeah, well, and other ways, yeah. But they kind of built it in for it. Yeah, there's like ways to do like the C++ optimization is just really fast, and so you just want to have a Python scripting of calling this, and it works pretty cleanly.
Oh, okay.
But there again, like that, yeah. So it can be done good or bad. But you're saying that Swift like Objective-C is done pretty well.
This one was done really well. Like I took an Objective-C library and added it to some Swift code, and it just worked. I was actually rather surprised. But I think the reason why it works so well is because of this LLVM middle.
And that's
middle
important
layer.
for a new language, because initially there won't be a lot of Swift libraries, right? So like it will be good that you can use the Objective-C libraries.
Yeah, I mean you basically get all of the Objective-C libraries you kind of just get for free, which is pretty cool. Cool. So yeah, there's a blog about Swift. There's a Reddit subreddit on Swift, and check it out. It's pretty cool.
And you can be one of the first. It's still time to get on the ground floor.
That's right. I mean, if you make even something which you might think is mundane, like I don't know, a calendar app or some library to help you, talk to Facebook or something, I don't know, and you use Swift, it could actually end up being really, really, really popular because there's not many out there.
Or you could like fall into like some sort of, it could bomb, right? Like we don't know. You like it though, so Jason sounds like he gives it a thumbs up.
Yeah, I think it's pretty solid. One thing they're on the fence about, I'm not crazy about the fact that this isn't like an obvious decision, but they're still trying to figure out what to do with the compiler, like whether to open source it or not. Like if you read blogs from the developers, the blog literally say we don't know whether we're going to open source it yet. And that always makes me uneasy because if you don't open source it, it really can't gain traction.
Well, it could, but it's just very dependent on, in this case, Apple, right? Like if Apple decides for internal reasons to cancel it, it may have been a good, like community may have wanted it, right? But like Apple decides not to do it. They could open source it at that point, but it's always better to kind of open source it early and have input and everybody on board from the start.
Like what a disaster C# was. Like C# is actually still surprisingly popular, but
a lot of people write C# code.
They had Mono, which was like the open source that's to basically reverse engineer all of C#. And then for a long time, Mono didn't work 100% the way C# did, like the Microsoft compiler did. And so just the whole thing was kind of a nightmare. And by the time it stabilized, I completely lost interest. But let's hope that doesn't happen here. So.
All right. Well, thanks for all of the letters, emails, and postings. We see them occasionally although we just talked about how antisocial we are, but we do see postings on Google Plus and Facebook and Twitter and the emails, and we do appreciate their community involvement.
Yeah, definitely. We definitely, we've been making a habit of talking about an email or a Google Plus or Facebook post in the beginning of the show, and that's because we've been getting so much good content from you guys and so many good questions.
We'll probably offend a bunch of people because we don't talk about theirs.
If we offended you, send us another email.
You can get all the money you paid for this back.
Yeah, that's right. Oh, man.
But I can't give you back the hour of your life.
No, that part you can't get back. So, but you can't give us back the bandwidth either, so we're even.
Okay. This is Devel. All right. Till next time.
All right, guys. Catch you later. The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.